Let's talk about LeetCode 3122. Minimal number of operations to satisfy conditions. It gives us a two-dimensional array grid. And you say that in one operation, you can change the value of any cell to any non-negative number. And you need to perform the operations to meet this condition. That is, each of the cell below it should equal to the values of current cell, and each cell which on its right should be different to current cell. So return the minimal number of operation needed. So it gives us an integer array that is grid. It looks like it is two-dimensional. But the things that let's look at this kind of example, this question. Grid kind of confused us. The things that if the final result is that for we want to make every column will have the same value. So if we can think out of the box about whether it is think this as a matrix, we can consider this as a array which has a column a number size of the array. And because the things that we want to make every column to be the same number. Here, it says that there is some kind of conditions that the number can only be from 0 to 9. So there are only 10 combinations. So this question, for example, we have a column number of array, right? So what, for example, for this column I, if we want to change it to number 5, right? We can calculate its cost. So how can we calculate its cost so that it's in the ith column, right? We're trying to see in this column how many 5s, how many other numbers. So so the row in this grid can use be calculated to be the cost, right? So that we know the cost in this row, the cost in this column to change to this number, we have a function called to calculate, right? We use a row to calculate the cost. So this question will be translated to for an one-dimensional array. The array size is the grid column size. We want to have every number to be different for adjacent number. What's the total minimal cost? Right. So let's think about this way. That is because every number can only be changed to from 0 to 9, right? And if this is changed to 0 to 9, for example, this is changed to a number 7 here, the second column we cannot change to 0, right? So it can change from 0 to 6 and 8 to 9, right? So what we want is that we want to know what is the minimum cost, total cost. We change from front to end, so that every adjacent number, they don't have the same number. Every adjacent cell, they don't have the same number, right? So apparently we know we can have n multiplied by 10 size DP array, right? So what does this kind of DP I, J mean, right? Or we'll say K, column K, right? So the first dimension is the column number, and the K is changed from 0 to 9, right? for this column, so dp column k, well, means at this column, all of the number change to k. What is the minimal cost? Total cost from left. We can add it to current, right? So that in the end, what we want to retain is the dp, the column, for example, it is n minus 1, and k, find a minimal value in this, right? K is from 0 to 10. So let's write code for this. We know int m equals grid dot length, and n equals grid 0 dot length, right? So we're going to say let's say dp so intuitively we want to have int, for example, dp, right? Equals new int n multiplied by 10, right? And so we know how do we calculate the cost, right? The cost is that for every column we want to calculate its counts, right? So of course you can have counts, counts equals new int n 10 as well, right? So here the counts actually and dp, those n we can all get rid of this dimension. But first let's write those kind of most intuitive way to solve this question so that we may easy to understand. So for int column equals 0, column smaller than n, column plus plus, right? So we'll say count, so that we have a column. Let's calculate, right? So we know we need to have int row equals 0, row smaller than m, row plus plus, right? So we'll have counts column row, right? This is reversed because apparently we will get rid of this first dimension a bit later. So so this is not a row, should be grid row column. This number, right? So yeah, increase by 1. So we know for every int k equals 0, k smaller than 10, right? K plus plus, and we're going to have dp column k, right? Should be we know we don't need consider dp column minus 1 right now. We just want to see the cost for this column. If change to a number k, it will be m minus column counts column k, right? Then what we do is that we'll say if this column is greater than 0, right? We should pass in the previous column's costs, right? So we can use int v equals integer dot max value. And then we'll say int L equals 0, L smaller than 10, L plus plus, right? So that means that we need L doesn't equals to K, right? So if L equals K, then we need to continue, right? Otherwise, what we need is that we need to have V equals max dot min BP colon minus 1 L and V, right? And here, then we'll have if column greater to 0, we'll have dp column k should plus equal to previous the minimal value, right? And in the end, we have int result we equals integer dot max value. So what we do is that for int k equals to 0, k smaller than 10, k plus plus, result should be max dot min result and dp and minus 1, okay, right? And in the end, just return result. This kind of approach, it will pass, right? But there are a lot of things we can improve. Here, let's think about the time complexity will be n multiplied by 10 squared, right? So column number counts multiplied by 100. So and space is 10 multiplied by 10, right? So let's try to see if we can increase the space complexity first. Let's see for every counts, right? Actually, we can reuse this column. It doesn't depend on the previous counts. Now also DP only depend on the previous DP, right? So we can both have this to be one dimension, right? So we can save space here. So So in this way, what we do is that this count, so we don't need to have the column one, right? So every time we calculate, we can have for example, arrays here counts to be 0, right? So we reuse these counts. And for DP, right? We know we can we just depend on the previous DP. So we can create something called a new DP here, right? So we can use create a new DP equals new int 10. Then what we do is that we know new dpk, right? New dpk equals counts Okay, right. So if this one greater equal to 0, and so this dp is previous column, right? Previous column. And then we'll have new dpk plus equal to v. And in the end, we just set dp equals new dp. So that we and we don't need this column as well, right? So we do this kind of approach to be the time complexity will still be n multiplied by 100, but space we'll see it will be only O10, right? So that will be constant. A moment ago is n multiplied by 10. And actually we can still improve because you see this K, right? We are iterate current column if we change from 0 to 10, right? And for the previous one, we also iterate 0 to 10, right? So do we need to do these two for loops? Actually, we don't. We can use because you see, if we have we can pre-calculate the previous our previous dp, right? Those kind of minimal value to its right. For example, I want to calculate the current dp5, right? But the previous, if we have we call right mean, right? That means the dp6 to 9. Those kind of values we already calculate, right? And we can pre-calculate, for example, called right mean dp for the previous dp from 0 to 9, right? And what we calculated is for our current dpk, new dpk, right? So we just iterated the right mean of the previous dp. And also for the left mean, right? So every time we iterate current value, we the left we are working on the previous dp, find the minimal value, right? So the minimal value we don't need to use the two for loops. So we use a left mean and also pre-process the right mean. Just iterate like divider board, right? And so that it will be O10 operations. So we can simplify this approach. So let's also simplify this approach. So what we can do is that here we have we don't need to touch this, right? And what we do is, for example, we pre-calculate for the previous dp, that is the column -1, right? So we say have something called a right mean dp equals new int 10. Then what we do is that we'll have right mean dp9. Let's set this one as integer dot max value, right? So let's do this in reverse order. That is for int k equals 8, k greater equal to 0, k minus minus. So we'll see how right mean dp k will be max dot mean dp k. We'll say this dp is the previous column, right? +1 and right mean dp k +1, right? So now we see, because we process here, so we don't need to we don't need to have this condition, this for loop, right? And also you'll see, and if we set this kind of value, if it is previous the first column, it still works, right? Because it will be 0, right? Um, at least it will not affect the result, right? You can also set this one. You set this one as integer max, right? Because uh um uh doing this process, so it is this for loop we can simplify. So what can we can write is still, right? We need to see how many, calculate the costs. Then here we can simplify as for example, int v equals max dot mean. Let's have int left mean dp, right, equals integer dot max value, and this will be mean left mean dp, right mean dpk, right? So that we'll know for this one, it doesn't include dpk, right? So you'll see every time we skip the dpk. And also because this is from dpk plus 1, you see, right? Then we'll see also we need to update the left mean dp, because the left mean dp we didn't pre-process. We can also pre-process to create another left mean dp as well, right? But left mean dp we can just use a variable. Then we'll have this one as mean dpk and left mean dp, right? And also we'll see new dp, right? New dpk with plus equal to v, right? So this will be the code to simplify the time complexity as well. So doing this kind of approach, we'll see it will be O(n) multiplied by 10 time complexity, right? And the space is 10, O(10), right? The constant. You see very fast. And we can also write Python code for this. So we'll say int m(n) equals length grid and length grid 0, right? And we need a dp equals this one multiplied by 10. And also we need a count also be the same, right? So this one multiplied by 10. So for column in range n, right? So what we do is that we can pre-process the previous column, right? So it's called right mean dp, right? dp is always the previous column's dp, and new dp, ndp will be current column's dp, right? So that would be float for example, IF multiplied by 10, right? So for K in range 8 minus 1 minus 1, right? And we're going to have right mean dp equals mean dp k plus 1 and right mean dpk, right? And right mean dp k plus 1, right? Then we need to calculate for current column the counts, right? So that means that is actually the cost function. So for every row in range M, then we're going to have a count, grid row column should plus equal to 1, right? Then we for the left min dp, right? We can use a variable. Of course, you can also create an array pre-process, but normally we like to use a variable to save space, right? Even it's not starting to change the space space complexity, but use variable here, right? So let's say the new DP also need to have this one multiplied by 10, right? So for K in range 10, right? That means for current column, if we change the number to K, so we'll say new DP K, it will firstly need to have the cost to be the row counts minus the counts K, right? And also we'll have min equals V, this kind of V. That means it's from previous one, right? That will be L min dp and right min dpk. And also we'll update the left min dp because we didn't pre-process. So we'll have min dpk and L min dp, right? And also we'll have n dpk should plus equal to V. And after that, we set dp equals new dp, right? So in the end, we just return the last, that's the main dp, right? So just we trying to see this area, what's the minimal value. So after that, this dp is the last columns dp value, right?